Hello everyone, welcome. It is Edmond here. This is a walkthrough of 2025 S1 summer series. I'll explain the concepts and see how we reach the correct answer. This is a continuation and we go to question number 3. Question number 3 says that Commodores are cheap, a quick way to represent to make predictions about the real world situations. Give one other reason why these models are used. Now, one reason I can put forward is that the models can be repeated, or like you can modify it, can be repeated, modified, and then adapted. That means if you make your model and you feel like the first experiment is not working, you can always change it and then do another experiment cheaply, because the value set is cheap. So they can be repeated and can be modified. Okay, we go in the question here. What we have Madison here wants to develop a model to describe the relationship between the average daily temperature, that's T, and the household daily gas consumption, that's D in meters cubed. What Madison does, it takes a sample of 12 days in winter and then records the daily consumption D. But after recording that, he's going to code the data. He codes the data. He changes D into another variable, which is W. We shall see how this is going to affect our calculation. Then we have the summary statistics over here, what he calculated. And the question A is asking us, question B is asking us to find the SWW. Now, this formula, the formula for SWW is the formula booklet. If you check SXX, so by now you have W, so I'm going to have SWW as equal to the summation of W squared minus the summation of W all squared divided by N, the number of sample units. So SWW is going to be the summation of W squared, which is already here, 10036.45 minus summation of W, which is 339.25. All this is squared divided by the sample units, which is we have 12 of them over there. We have 12. Now, when you press your calculator, this number here is going to end up to be exactly that number. It's going to be end up 445.5697, which is 445.57 to 2 decimal places. All right. Now we move on to part C, parts of the equation, which is STD. Now, STD in the summary, all right, over here, STD. In the summary, which has been given, we have STW. But remember, W is, I'll change the color here. I'll change the color. But remember, W was found by coding D. So if you make D the subject, D is W divided by 11.5. So STW is going to be STD is going to be STW. I didn't write it that good. I'm going to have STW. This is STW divided by 11.5. So our STW, STD is going to be the STW, which is negative 91.55 divided by 11.5. Then you can press your calculator, then come up the answer. This is going to be negative 7.96087. So that is STW. Now, how did I do this? I'm going to erase this and I'm going to explain this more. And now let us try to understand what we did here to try to find STW. Now, when you're trying to find STD. Now, if you're trying to find STD, the formula is going to be the summation of T times D minus the summation of T and the summation of D, all of it over N. But what you have D was just coded. That means from here, D is equal to W over 11.5. That means this is going to be the summation of T times D, where D is W over 11.5 minus summation of T multiplied by summation of D, but the summation of D is going to be the summation of W over 11.5, all of it over N. So the 1 over 11.5 can be factorized out, and still we get summation of T W minus, still even over here we can factorize the 1 over 11.5, and still the summation of T and summation of W, all of it over N. That means that N is just 1 over 11.5 into summation of TW minus summation of T, summation of W over N. That's why STD is just 1 over 11.5 of STW. That's why we just say that STD is equal to STW, which is negative 91.55 divided by 11.5. Let us try to see now the SDD. Now, SDD, we are going to look at it as the variance, because this is the sum of all the variations. Because if I'm looking for the variance, is always going to be the S of x over n. That's going to be the variance. So this is like the sum of all the variations. So these ST, STW, STT, STD, they behave like variance. So if we have ST, we have SWW, and we're looking for STD after a coding of D equals to W over 11.5. That means even STD is going to be like the variance. Remember the variance formula where we say that the variance of AX is going to be AX squared times the variance of X. That means STD is going to be equal to 1 over 11.5. This is squared multiplied by STW multiplied by ST non STW multiplied by SWW. I'll erase this. Where's the eraser here? Multiplied by SWW, because that's a coding. SWW, that's the coding of D and W. That means your answer is just SWW, which you have as 445.57 over 11.5 squared. When you press your calculator, what do you have here? You end up with 3.3691. Okay. But sometimes you may not be able to see this, so I'm going to give another way of seeing the STD, the same way I explained the previous one. I'm going to erase all of this. Another way of seeing STD. Another way of seeing STD is still seeing it from the formula that it's going to be the summation of D squared minus the summation of D all squared over N. That means by the summation of D, remember D has been changed, has been created from W. That means D is W over 11.5 squared minus the summation of D, which is going to be the summation of W over 11.5 squared, all of it over what? All of it over N. Now when you see this, you see that when you sum up, so you are going to end up with summation of W squared over 11.5 squared minus the summation of W squared, all of it over 11.5, but all of it over what? Over 12. Now that means I'll get the same answer if I get the summation of W squared, which is going to be 10.10036.45 over 11.5 squared minus the summation of this W. This is all squared. This is not outside. This is outside, all squared. And summation of all squared which is going to be summation of W all squared, which is where is it? Over here, 339.25. You divide this by your, this is squared as well because open the bracket, 11.5 squared. Now all of it over what? Over 12. You can play this on the calculator and see the answer is going to be the same. This one is all squared here. So then when you press a calculator, you're going to end up with exactly the same answer. So you can see it in two different ways. Okay, I'm going to erase this, but we have the numbers. You can always play back the video, or you can always check the numbers that you have got already here. I'll erase this and go to the next question. Okay, the next one, we are looking for the product moment correlation coefficient between D and T. Now our R, the product correlation coefficient, we know that this is going to be S of dt over the square root of, the formula is the formula booklet, so there's nothing to worry about, dd. That means what we do, we substitute in our formula. We have STD, which we calculated already in the previous, in part C. We already got these values in part C. You can check your values. The STD was negative 7.96 over the square root of STT. STT is over here, which is 26.43, multiplied by STD, which we've just found, which was 3.37 if you round it. Then you can place your calculator. You can use a more accurate value here, remember it was 3.691. Your calculated value. Even up here you can use a more accurate answer, and then you get your R. When you play this in the calculator, you end up with your R as negative 0.8436. For the correlation coefficient, you can as well use WT. Yeah, you can as well use WT and say that your R is equal to SWT over the square root of SWW and STT, because the correlation does the coding, the linear coding which they did over here does not change the correlation. So even if you use this, you end up with the same answer. Then give your interpretation in context. Remember what you have here is that the correlation is a negative correlation. So what you need to say, you need to tell us that when T increases, when the temperature rises, the gas consumption goes down, the gas consumption decreases. So what you have to tell us here, that an increase in the temperature will lead to a decrease in the gas consumption. That's your interpretation. Let us go to the next part of the question. The next part of the question, okay, part F. Part F is asking us to find the regression line between WT. This is very simple because they have already given us the equation. So we always start with the B, that's the gradient. Remember, looking at this line, we always start with this one over here. This is going to be the gradient. You know, the B, this is T and what? T and W. So the gradient, that's the B, is going to be equal to S of TW over S of TT. This formula is given in the formula booklet. But we know we have ST of W, which is negative 9.591, not 9, this 91. This 91 from our from this one over here, STW negative 91. Change this here, negative 91.555 over STT. STT was also 26.43. Then you can have your answer. This is going to be exactly the same answer like that. When you round it up to, it's going to be exactly the same. 638. Round it up to 3 scan figures, you end up with the same value. And then the next one is the C over here. Remember the formula for the C. in the formula booklet, you see it as A will be equal to W bar minus B times T bar times T bar. That means our A is equal to W bar. W bar, you're going to use the sum of W, which was 339.25 divided by what? Divided by 12 minus your B, which you have just got. You can use the more accurate value, 3.4638, multiplied by T, which is the average of the T. You can check the total for T. The sum of T was 9.1, so the average is going to be 9.1 divided by 12. And when you press your calculator, you're going to end up with 30. Press the calculator here. It will be 30.897, which rounds to 30.9. That's the first part of it. Now, the next question, they are now asking you to change your regression line. I'll change the color here. They want you to change the regression line to have the regression line of D on T. D on T means that all we are doing here, we are replacing W with D. But we know from our coding here, W was equal 11.5 D. So we just replace W with D. So what you're going to do, so you're going to replace this, the W in our equation, with 11.5 D is equal, guys, I'm answering, this is part G that you're answering, equals to negative 3.446 T plus 30.9. That means to get your D, you just have to divide everything by 11.5. So minus 3.46 T divided by 11.5 plus 30.9 divided by 11.5. We can press the calculator here, and then you shall see that our D is equal to negative 0.301 T plus, when you divide this one over here, you get 2.669. This rounded, I didn't say round it, it's rounded to 3 significant figures. Yeah, that's that part. We go to the next part. I'll change the color here to the next part. We have part H. Part H, they have told us to use our equation G. We want to estimate the consumption at 2. That means we have the equation over here. So that means for H, we are estimating D, but we've been given T is equal to 2. So this is just a point of just substituting in your equation, 301 into 2, and then plus 2.669. Then you end up with your D as 2.0852. You can give to these kind of figures, so you have your 2.09. The next part over here, interpret the effect of one increase of this is the T. So what happens if T increases by 1 unit? What's going to happen to the daily consumption? Now, the increase of T by 1 unit, this is going to be the interpretation of this, the interpretation of the gradient of the model. So the interpretation of the gradient of the model is that if T increases by 1 unit, I'm looking at part 2 of H. If T increases by 1 unit, the daily consumption, here it's negative, is going to go down by 0.301 meters. Remember, the units for the D is meters what? Meters cubed. That's in for D. So this is the interpretation of the gradient. That's what they're looking for over here, that if you have an increase of 1 unit in the temperature, what's going to be the effect on the consumption? The effect on consumption is going to go down by 0.301 meters cubed. That's the volume of the consumption that's going to go down. So that's you just have to say, so the answer for this one over part A, you just say that the consumption will decrease by consumption will decrease by 0.301, like that. All right, that's question 3 is done.